Hello, I'm Dr. Sam Hancock of the Emerald Planet and Emerald Planet TV. We come to you on a week-to-week basis from Washington, D.C. in the United States as we look around the globe in 144 different nations, looking for those 1,000 best practices, the technology, services, and products that are making a difference as we move through the 21st century. And as we have a planet of 9 billion people by 2038 and possibly 12 to 13 billion by the end of this century, how are we going to be able to take care of all these people on planet Earth? And that's what Emerald Planet's all about. We come to you looking at the solutions, the best practices from around the globe as we create the Emerald Planet. Hello, welcome to the Emerald Planet. We're making a difference as we move through the 21st century. And seeing the long-term impacts of climate change. We're glad to have you. Thank you for being with us.
Looking around the globe for the major issues facing planet Earth, of course, centers around water and managing water in areas where you have too much at some times and then droughts almost immediately following. We have someone that's coming from the Technological University of Darmstadt in Germany. This is Professor Christoph Schüth, and he's talking about MARSOL and MARSoluT projects. And these are very important as far as where we're going to create what's known now as new water. So Christoph, welcome to the Emerald Planet TV.
Thanks for having me.
We're glad to have you here. Tell us a little bit about the history of your university and why is it so much involved in this MARSoluT and the MAR movement?
Technical University of Darmstadt is one of the technical universities in Germany, and these technical universities are focused on solving problems, actually. And the University of Darmstadt was founded more than 100 years ago, about 150 years ago. And this is mainly engineers, but also some part of the university is natural sciences. And together with the engineers, the natural science group is developing solutions for one of the major problems that we have in our world, and this is the access to enough and clean water.
Yeah, and looking at this chart here, this is something that we've been sharing about this MAR. Why is the management aquifer recharge becoming such a topic literally every place on the planet Earth?
This is because there are several reasons for this. One of the first reasons is that we have, of course, a growing population on Earth and we need more and more water. The second reason why it's becoming an issue is also that we have climatic changes. So we have in places of the world less water available, but we need to supply more water to the populations. And this is why we need alternative solutions. And managed aquifer recharge is one of these alternative solutions. What we make use of is the storage capacity of the subsurface to enrich groundwater resources in times when we have enough water and even an excess of water, and we can use that water then in times when we have a deficit of water and when we need it actually. So the subsurface acts like an intermediate storage.
Yeah, and looking at this, really what you're doing is you're evening out the flow, no pun intended, as far as water is concerned. So if you have a drought, you still have sufficient water for those times. But when you have massive flooding, you're actually capturing that water and storing it underground. Is that the broad concept of what you're doing?
That is a broad concept because we have a mismatch between water availability and water demand, actually. And this mismatch can be covered by intermediate storage. And one of the water sources that we can use is runoff. If we have high precipitation rates, we can capture that water. But of course, there are other water resources available, like treated wastewater, which typically has a pretty good quality. And these sources can also be used and can be infiltrated for later usage.
Now, looking at the work that you are doing, you're going across much of the European Union. We have the 8 countries listed here. Why is it so critical that you do this research, the studies, and the publishing, which is very important as far as these 8 countries?
What you see here is that these 8 countries are located in the southern part of Europe, in the Mediterranean. And if we forecast how the climate change will affect these countries, we might experience a 50% decrease in the available water resources by the year 2100. So we have to prepare, actually. And this is why we actually looked into the Mediterranean area.
Now, there's a number of techniques that you're using. All of these are very practical. But what are we looking at here, Christoph, that allows you to start preparing for evening out the availability of water from drought to flooding and back to drought?
What you see here in this slide is 3 different examples of managed aquifer recharge schemes. And this is also the concept of the MARSOL project, or was the concept of the MARSOL project, that we use basically different experimental setups, different field sites, different sources of water to cover a very broad range of available water resources for storage. And that also made the project so interesting and so important, because we are not focusing on one specific source. We are covering a huge range of different water sources and different infiltration mechanisms that we have in order to find the best solution for a specific place.
Now, looking at this chart that we have here in front of us, tell us what we're looking at and why is this so important to understand, and also very important for the public to understand that there are professionals just like you that are looking at their needs and making sure that we're taking care of them way into the future.
What we are looking at here is basically different examples of how water can be infiltrated into the subsurface. We have on the left side flooding irrigation, so we spread water on the surface. We have in the middle basins or ditches, so which are dig into the ground, and we might also have wells or shafts where water is directly infiltrated into the subsurface. What we also see here is that the unsaturated zone, this is basically where we infiltrate the water into, can be used to polish water quality. And the thicker the unsaturated zone, the higher there is the retention capacity to remove, for example, contaminants that might be still present in the water. So if we have a thick unsaturated zone, the retention capacity is very good for contaminants, and the source water quality can be basically somehow not as good as compared to the example that we completely infiltrate the water into wells, directly into the aquifer. So the source quality has to be very good if we directly infiltrate into wells, into the aquifers, and it can be of less quality if we have a thick unsaturated zone where the infiltrated water can be somehow improved in quality to microbial degradation processes or sorption processes, removing contaminants from the water phase.
Now, looking at let's stay on this, Christoph, if you don't mind, for just another question in a minute. One of the things, as far as most water experts, they're always looking at quality, and they forget about quantity. And as we move forward through the 21st century, less and less quantity is available to many communities and many countries. So how what we're looking at right here, Christoph, helps to balance quality but also quantity?
You're raising there a very important point. Of course, there's quality aspects. This is very important, but the quantity basically is also a driver of our research. The quantity issue can be addressed by saying, I do not need the same quality for every purpose. You know, if I produce drinking water, the quality has to be different to water that I might use for agriculture or for other purposes.
Right.
We call this concept fit for purpose. So you have to treat the water according to the expected need for the water. If you need it for agriculture, you can treat it differently, or you can even reuse water for agriculture without much treatment. So the quality aspect is one thing, and the quantity aspect is another thing, and they are connected somehow by this thinking that you need a specific quality for a specific reason, actually.
Now, looking at the beneficiaries and the partners as far as this MARSOL, you are the coordinator for this. Tell us a little bit about this broad collection, both beneficiaries and partners.
What you see is exactly something that is needed for projects like this, we have beneficiaries, that's the people involved getting money from the European Union in this case, and we have the partners that are very interested in the output of our research. And what you see here is a collection of research institutes, of universities, of companies, and also about regulating agencies. So you need the whole range of stakeholders in order to make a sound project. Yeah, it doesn't make any sense just to do research without connecting that to companies later applying that research and to regulatory agencies that have to somehow develop the regulatory framework, how this technology can be used later in the field. So this was the general setup. We have partners from research, from universities, from companies, from regulating agencies. And that makes completely sense if you have a technology that you would later apply in the field.
Now, how does this give comfort to, there'll be millions of citizens watching this across 214 countries and territories. Just this simple chart, how does this give them comfort that you really are the professionals, the researchers in water, really looking after their benefits and their future and their families?
What you, for example, see here in terms of partners, on the right-hand side, you see MARSoluT, for example, and MARSoluT is the water supply company of Israel. So these are the people responsible for water supply of a country. And they are involved here as they are expecting that the results are usable for them. The next point I would like to make is I'm a researcher. And what we do as a researcher, we produce output in terms of publications. Publications go through a review process. So colleagues of mine get these publications, they look at it, and they determine whether it makes sense what we do or not. And if it makes sense, it's published. And we publish, of course, our results a lot, and all partners do that because we are open for discussion also. So the results we present are discussed, they are acknowledged, and if they are okay, they are published. And this output gives us confidence that what we do is correct and what we do has a kind of scientific basis.
Now, looking at this very complicated structure, I don't want to spend a lot of time on this. But again, going back to the quality versus quantity issue, or I shouldn't say versus, quantity and quality issues, how does this directly relate to that and the research that you are doing at your university?
What you see here in this slide is basically the setup of the MARSOL project. And I brought that up because I wanted to show you how complex such a project can be and all the factors you have to consider. If you, for example, focus on this activity line 3, you see everything that is involved in such a large project. It's investigation and monitoring techniques, modeling techniques, technical solution, benchmarking, water quality. The economy, of course, also has to fit because it doesn't make sense if it's too costly to do something like this. There's technology assessment risks. You have to evaluate the risk of such a project. And in the end, it came out to be one of the most important factors. It's legal issues, policy, and governance. You have to have rules how to apply such a technology. And this has to be done in accordance to the policy of the European Union, for example, because they gave us the money to do that. And they were also asking for suggestions how to implement this in terms of legal issues.
Okay, we're going to leave this up just to show how complicated the laboratories are and how you're really taking good care. But within the 20 seconds we have left, Christoph, why is this MARSoluT so important, and what do you see for its future? And we got to be quick.
Yeah, well, what I would like to state in the end is that managed aquifer recharge is a sound, safe, and sustainable strategy that can be applied with very great confidence. This is one of the pieces in the puzzle to show our water problems in the future.
Fantastic. This is Professor Christoph Schüth of the TU Darmstadt. Thank you as we create the Emerald Planet.
Thank you for giving me this opportunity.